Chapter 7, which is about integrals. Differential calculus we already studied. Differential calculus. Differential calculus means the study of limits and differentiation. Study of limits and differentiation. Now here integral calculus, this is integral calculus. So this is a part of calculus which is integral calculus. We'll see it in detail here. A method of finding integral, which is also called antiderivative. Integral or antiderivative. A method or procedure of finding integral or antiderivative is called integration. Here. So basically integration is a procedure to get the antiderivative of a function. Integration is a procedure of getting antiderivative, or it is also called the integral of a function. So it's a procedure. Okay, now what do we understand by this? In this way. For example, you know d by dx of, for example, let's write sin x. You know derivative of sin x, which is cos x. So we say that here, we say that integral of fx equals to cos x. Here let me write the cos x function is nothing but this sin x. Reverse procedure, you see, or you can call this is the inverse procedure of differentiation. You are doing inverse of differentiation. What is derivative of sine, which is cos? Now we say that integral of cos equals to sine, and we write like this symbolically. We write, this is a symbol. Here we write like this symbol and dx. You know that this is a symbol for derivative, d by dx. This is a symbol for differentiation. Here these and this stands for integral with respect to x. You know that this stands for derivative with respect to which function? Cos function. So I'll put here cos x equals to which function? That is sin x. So this is a symbol. This is read as integral of cos x with respect to x equals to sin x. Right? This entire symbol. So these and this one and dx, that's a symbol for integration. This is a function, right? Integral of cos is sine, means if I differentiate this function, this is basically definition. If I find the derivative of this function, I must get this. I repeat, when I say that integral of cos equals to sin x, it means if I differentiate this function, if I differentiate this, I must get this function. This is the meaning of this symbol, remember. Now you see here, if I write like this, for example, in this case, if I write derivative of sin x, I'll get the cos x. That means integral of cos x equals to sin x. If I write integral of differentiation of sin x plus 1, again cos x. Therefore I can say that here also therefore I can say that the integral of cos x equals to sin x plus 1. Why? The question is why integral of cos x is sin x plus 1? Answer is very simple. You differentiate this function, you will get this antiderivative procedure, remember. One more, if I take example here, if I write sin x plus 10, what's the derivative? If I differentiate this, you will get the cos x here. Therefore, I can say that integral of cos x, I can write now Sin x plus tan also. Question is, why integral of cos is sin x plus tan? Answer is very simple. You differentiate this function, I must get this. Fine. So in general, I can write here, therefore integral of cos x equals to not only sin x but sin x plus some constant c. So always in integration, when we write the answer, we write the plus c. Here c is called constant of the integration, where c is called constant of the integration. Constant of the integration. C is called what? Constant of the integration. So in integration procedure, in antiderivative procedure, when you write integral of some function, always we write the plus c, remember. I again emphasize, why integral of cos is sin x plus c? Because if I differentiate these, I'll get this. You find derivative of this, I must get this. So for example, now you can say that integral of 1 with respect to x, integral of 1. So what's the question? Find one function whose derivative is 1, which is x. What's the derivative of x? 1. And always you will put the plus constant c. So integral of 1 is x, remember, plus some constant c. Again, one question might be there in your mind, why integral of 1 is x plus c? Answer is very simple. Differentiation you already studied. You differentiate this portion, RHS portion. You must get this. What's the derivative of x? 1. What's the derivative of c being constant? 0. So answer is 1. So therefore integral of 1 is constant plus some c. Always we put plus c in the answer of the differentiation. Here you have 1, here you have 10. It can be any constant. So in general we put the plus c. If I write here one more, what's the integral of e raised to x? So find one function whose derivative is e raised to x. You know derivative of e raised to x is itself. So answer is e raised to x plus some constant c, where c is a constant of the integration. C can have any value. So c is called sometimes arbitrary constant. Arbitrary constant. Arbitrary constant means what? It can take any value in general, remember. It's not like constant pi or e, you know. C is a constant of the integration. It's sometimes called arbitrary constant. Arbitrary constant means it can take any value, remember. What you need to do is, whenever you integrate some function, you need to write plus c in the answer. Now, I hope this symbol is clear to you. One more if I write, let's write one more example here. For example, let's write third one here. Integral of sec square x. What's the meaning of this? That means you find one function whose derivative is sec square. So you know the corresponding function is 10x. What's the derivative of 10x? Sec square. So integral of sec square is 10x. And we write plus c, where c is the constant of the integration. I again repeat, integral of sec square is 10 because if I differentiate this, if I get the derivative of this, I must get this portion. This is a function. You differentiate 10x plus c, you'll get this function. So integral of sec square x is 10x plus c. One more, if I write one example here, let me write sec x into 10x. You want integral of this, right? So what's the question? Find one function whose derivative is this. So you know such function is sec x here. Sec x plus c. C is called constant of the integration. What's the derivative of sec x plus c? You differentiate this portion here, you'll get exactly this much. So therefore integration of sec x into tan x is just sec x, remember. Where c is constant of the integration, so derivative is 0. What's the differentiation of sec x, which is sec x into tan x? So this is basic definition, remember. Integration is also called, as I told you, integration is nothing but anti-derivative procedure, anti-differentiation procedure, reverse of differentiation, remember. it's like you do the reverse of what you did in the differentiation. So these two processes, differentiation and integration, differentiation and integration, these are nothing but reverse or inverse processes. Inverse process, remember. You start with function, differentiate it, again integrate it, you will get the function back. Remember that way. You start with function, integrate it, again differentiate it, you will get the function back. This nothing but the inverse procedure or inverse processes or reverse processes. Remember, integration and differentiation, you can say here reverse or inverse processes. Okay, now if I write precisely definition, it's like this. If we know that d by dx of, for example, let me write fx equals to, let me say small fx, then we can say that integral of big fx equals to this one, that is fx, small fx, and here you can add, in the differentiation you can write plus c, so here also I can write the plus c. There is the definition. This is just I wrote for your information. The meaning of this is, when I differentiate this function, I must get this. That's what I've written here. This is the general formula. The concept is just antiderivative procedure, remember. For example, you know this. What is, you just recall, what's the differentiation of x cubed by 3? 3x cubed by 3. So here, if I differentiate this, you will get 3x square. So 3 will get cancelled, you will get x square. So I can write here integral of x square equals to x cubed by 3. Here I can write plus c, because differentiation of plus c is always 0. Right? Why this? Because of this. What is the integral of x square here? X cubed by 3 plus c. Why? Because again, if I differentiate this function, I must get this antiderivative procedure. Fine. So this is definition of integration. Remember, integration and differentiation are reverse processes. In which sense, it's like this. You start with function. For example, I've started with, let's take sin x. I'll differentiate this first. I'll differentiate this. What you will get? What's the derivative of sine? Cos. Now find integration of cos, you will get sine. Integration. Start with a function, differentiate it, you will get new function, integrate it, you will get the function back. So if I start with function, I'll differentiate it, d by dx, and then I'll integrate it. So you will get an intern function fx. You have started with this function, you have differentiated, then you have integrated, so you are getting function back. Or you can do this way. You start with function, integrate first, this is a symbol for integration. Now you differentiate it, d by dx of this, again you will get the function back. So in that sense, differentiation and integration are reverse processes. Okay. Now with this, before I get into some standard results, I'll just state the all standard formulas of the integration which I already studied in differentiation. So some standard forms. So we start with some standard forms here. All are based on differentiation, remember. So the first one is integral of x raised to n, you know, power function. Integral of x raised to n, power function. For example, this x square. So here integration is given by x raised to n plus 1 upon n plus 1 plus c. Always, as I told you, we write plus c. What's the integral of x raised to n? That is x raised to n plus 1. Increase the power by 1 divided by the same number. Again, if you have the same question, why integral of this x raised to n is this? You can verify because differentiation you already studied. If you differentiate this portion, you will get exactly this. Reason, if you want to write as d by dx of x raised to n plus 1 upon n plus 1, you can just verify because differentiation you know now. Plus c, if I differentiate this, I will get exactly x raised to n. Right? You can just start here. N is a constant, remember. What this formula says, raise the power by 1 divided by the same number. So what is integral of x raised to n? Increase the power by 1. X cube by 3 plus c. Increase the power by 1 if I have this. If I have next one, for example, integral of x raised to 6, power function. How will write? Raise the power by 1. Increase the power by 1. So 6 power 1, 7 upon 7 plus c. You can answer why integral of x raised to 6 is this. You find derivative of this portion, you will get exactly this. But every time no need to verify. You just need to use the standard formula. Differentiate this portion, you will get exactly this. One more if I write here. Let me write one more example here. Third example. Integral of, suppose we have x raised to 3 by 2. Power function x raised to n. So what is answer to this? Raise the power by 1. So if you raise the power by 1, 3 by 2 plus 1 upon 3 by 2 plus 1 plus c. So this will be 5 by 2. So x raised to 5 by 2 upon 5 by 2, which is 2 by 5 plus c. This is the answer. Why integral of x raised to 3 by 2 is this? Because if you differentiate this portion, you will get exactly this. Fine. Fourth one now. Let me write one more. Suppose I have 1 upon x raised to 6 like this. So this is same as x raised to minus 6 here. Now same procedure, raise the power by 1. So if I raise the power by 1, minus 6 plus 1 upon minus 6 plus 1 plus c. And then this is minus 5. So minus 5, your power is also minus 5, x raised to 5 plus c. This is your answer. So this is use of the first formula. Integral of x raised to n is x raised to n plus 1 upon n plus 1. Increase the power by 1 divided by the same number plus some constant c. You might have noticed everywhere I'm writing plus c. Right? Okay. So that is one. Second one now. Fifth one, main formula, second formula. That is, let's go to integral of 1 upon x. So here, do you know any function whose derivative is 1 upon x? That is nothing but log function. So here log of mod of x plus c, remember. You can prove that d by dx of, probably you might have studied, I had asked in one of the MCQ in one of the exam, derivative of log of mod of x is always 1 upon x. Right? You know that the domain of log function is r plus. So in case if this number is negative, we need to make them positive. That's why we are writing here modulus, remember. So what's the integral of 1 upon x? That's a log of mod of x plus c. Modulus is there whenever you write answer in form of log in integration, remember. You can prove this very easily. This is not a difficult task. Show that the derivative of log of modulus x is 1 upon x. Where x may be negative or positive, answer will be always 1 upon x. So this is the second important formula. Integral of 1 upon x is log of mod of x. Okay. Third one, that is about exponential function, a raised to x dx. Exponential function. You know differentiation of exponential. That is a raised to x into log a. This is derivative. Into log a, you know. This is a differentiation. Integration and differentiation, you know, these are the reverse processes. You are writing into here. What's the reverse of into? Division. So integral of a raised to x is a raised to x upon log a, remember. Log a to the base e, it is understood, plus some constant c. constant of the integration. What's the integral of a raised to x? That's a raised to x upon log this number to the base e plus c. Again, same question. Again, I'm emphasizing, I'm repeating, why integral of a raised to x is a raised to x upon log a plus c. You differentiate this, you will get exactly this portion. That's why. Okay, for example, here, if I write simple example at this place, what is integral of 2 raised to x exponential function, remember? So it is 2 raised to x upon log 2 plus c. What's the integral of 2 raised to x? 2 raised to x upon log 2 to the base e, it is understood, plus c. Now from this we have here the next formula, that is about e raised to x. So fourth one, let me write here, fourth one, which is integral of e raised to x. You know, as I mentioned earlier, e raised to x plus c. You know, differentiation of e raised to x is itself. So this is your answer. Derivative of e raised to x is e raised to x. Okay, and same way integration of e raised to x is also e raised to x. So one is power function, integral of x raised to n is raise the power by the same number. The second one is here, second one is integral of 1 upon x is log of mod of x. Third one is this, you know, exponential function a raised to x upon log a. And fourth one is here, which one? That is standard exponential function. Integral of a raised to x is a raised to x here. Okay, now we go to trig functions here, fifth one. I'll write here integral of sine. Sixth one, integral of cos. Seventh one, integral of, let's write for example 10 function here, 10x. Eighth one, let's write integral of cot x here. One more, ninth one, let's write integral of here sec x. And 10th one, that is integral of, let me write cosec. So here for these standard functions, based on differentiation, you can answer some of the function. What's the integral of sine? It is nothing but here minus cos. Why? You can just verify, you differentiate this, you will get exactly this. Remember, derivative of cos itself is minus sign, so this minus and that minus gives us plus. What's the integral of cos? Sin x plus c. Now this we have not studied, but later on we'll see. You can verify by differentiation. The integral of 10 is log of mod of sec x plus c. You differentiate this by chain rule, you will get exactly this. Modulus is always there whenever we have log function as an answer of integration, remember. Don't forget to put this modulus. Why we are putting modulus? Again I'm repeating, because sec might be negative. Log of negative is not possible, remember. So in case if this is negative, this modulus convert into positive. That's why, remember. Okay. So integral of 10 is log of mod of sec x. You can verify by chain rule differentiation of this one. These I leave it for you. You differentiate this by chain rule, you will get exactly 10. Integral of cot, log of mod of sin x. Log is there, that's why I placed the modulus. I again repeat why I placed the modulus, because this number might be negative. Log of negative is not possible. In order to make it positive, we are putting the modulus. Now how do I check? You differentiate this by chain rule. You find the derivative of this one by chain rule, you will get exactly cot function, remember. Next one, integral of sec x, which is again in form of log of mod of sec x plus 10x. Right? Later on you will realize why this, but right now you can verify. If I differentiate this correctly by chain rule, you will get this. These are all the questions for you for differentiation, remember. Differentiation you already studied. So differentiate this, you will get this. Differentiate this, you will get this. Differentiate this, you will get this. Find derivative of this, you will get this. Find derivative of this, you will get this. And here, integral of cosec x, that is the log of mod of cosec minus cot plus c. Okay, so these are all standard trig functions. I need to emphasize on this too again. If you find by chain rule derivative of this, you'll get exactly this. So therefore integral of sec is this. What's the integral of cosec x? Log of mod of cosec minus cot. Why? Because if you find differentiation of this, you'll get exactly this. Now this next comes from the differentiation. Integral of sec squared. You know it is 10x. Why? Because differentiation of 10 is sec squared plus c. Next, 12th, integral of cosec squared. You know here it would be minus cot. Why minus cot? Because if I differentiate cot, you will get minus, and this minus gives us cosec squared. So integral of cosec squared is minus cot. Next, 13, integral of sec x into 10x, which, as I told you, what's the derivative? What is the integral of this? That is, you know here sec x, because here differentiation of sec x is sec x into 10x. And one more trig standard functions here, 14 number. Integral of cosec into cot. That is nothing but here minus cosec x plus c. Why minus? Because derivative of cosec itself is minus cosec into cot, and this minus gives us plus. So these are all list of the standard functions which you know. I repeat this here. One more thing, if you notice, if you have c then with minus sign in answer, remember c with minus sign and c with minus sign. That way you can remember if you have confusion about this. Answer of each of this. Y answer of sine is cos. Differentiate this, you will get this. Y answer of tan is log of mod of sec. Differentiate this, you will get this. Y answer of cot is log of mod of sin x. Differentiate this, you will get this. Y answer of sec x is log of mod of sec x plus tan x. That is nothing but by differentiation. You find derivative of this by chain rule, you will get exactly this. Similarly here also. So these four functions are new for you. The other just comes from the derivative. Integral of tan is log of mod of sec. Integral of cot is log of mod of sine. Integral of sec x is log of mod of sec x plus tan x. Integral of cosec x is log of mod of cosec minus cot. This just comes from the derivative only, remember. Now here, sometimes this can be rewritten in this form. If I simplify sec x plus tan x using the trig functions like this, you see here I'm simplifying sec x plus tan x. So I'm just simplifying sec x plus tan x. I'm keeping this as it is. So this is 1 upon cos plus this is sin x upon cos x. This is 1 plus sin x upon cos x. Now here this you can write as for example cos x by 2 plus sin x by 2 the whole square. You know this. This I can write, if you remember, half angle formula, cos square x by 2 minus sin square x by 2. Fine. Now further here, this is like a square minus b square. So it has two factors. 1 plus factor will get cancelled with this. So here you are left with only with this plus factor. And here you are left with just minus factor. Just check this. Now I'll divide this expression by, I want to convert into tan, so cosine. So 1 plus tan x by 2 upon 1 plus 1 minus tan x by 2. You know that this is nothing but tan, if you remember addition formula, tan pi by 4 plus x by 2. You know tan x plus y is tan x plus tan y upon 1 minus tan x into tan y. This is just trigo simplification, 11th standard trigo. So what I have derived is, in place of 1 log of sec x plus tan x, you can write here inside the modulus tan pi by 4 plus x by 2. So I'm writing this here equals to log of mod of tan pi by 4 plus x by 2 plus c, right? Both are the standard formulas. You can use this or this. Sometimes in MCQ you may option using this formula, so you can use this. Remember, you know what I did? We did nothing. Just in place of this, using 11 trigo, we have reduced in tan pi by 4 plus x by 2. Both are just same, remember. You can use this formula as well as this formula, whichever you use, both are same. Now same way here, cosec minus cot, if I simplify. So now I'm simplifying this much using 11 trigo. This is 1 upon sin x minus cot is cos x upon sin x. So numerator will be 1 minus cos x upon sin x. You know here this you can write in form of half angle, twice sin x by 2 into cosine x by 2. Half angle formula here, 2 sine square x by 2. All these things are from 11 trigo. 1 minus cos x is 2 sine square x by 2. 2 will get cancelled, 1 sine will get cancelled. So you are left with here sine x by 2 upon cosine x by 2. And what is this? This is simply tan x by 2. So in place of cos x minus cot x, you can write tan x by 2. So I'm writing here, this is equals to log of mod of tan x by 2, half of this angle plus c. This is another formula of cosec x. So now you have two formulas for sec x and two formulas for cosec x. What's the integral of sec x? Log of mod of sec x plus tan x, or log of mod of tan pi by 4 plus x by 2. Why this? 11 trigo, you know. What's the integral of cosec x? Log of mod of cosec minus cot. The another equivalent form is, instead of this you can write log of mod of tan x by 2. Fine. In the others formulas are obvious, but these are very fundamental formula which you need to remember. Now we move ahead with some inverse trigo formula. So next, integral of, next one, 15 integral of 1 upon root of 1 minus x square. So you can write here sine inverse x plus c. Why? Because differentiation of sine inverse x is this. You can write minus cos inverse x also, because what's the derivative of cos inverse x? It is minus 1 upon root of 1 minus x square, and this minus gives us this. So integral of 1 upon root of 1 minus x square is sine inverse x, or here minus cos inverse x. Both are same. You can write this as well as this. Meaning is same. Whether you differentiate this or you differentiate this, in both the cases the function will be this. Now sometimes instead of 1 you may have like this also. Integral of 1 upon root of a square minus x square. Remember. So in this case, this is a general formula. If you put a equals to 1, you will get this. So it is given by here. So here it is sine inverse x by a plus c. Why this? Answer is very simple. See, I'm just showing you differentiate this. I'm differentiating this just to verify. You will notice this. So differentiation of This is just for your information. Differentiation of sine inverse x by a. Use the chain rule here. Imagine this as x. What's the derivative of sine inverse x? 1 upon root of 1 minus x squared. That is x squared by a squared into, by chain rule, derivative of x by a. It is just 1 by a. Fine. This is simply chain rule. You are now, I'm sure, confident with this. So 1 upon, you take your LCM. So a squared minus x squared. This a square will come out from the square root. We assume that it is positive. I'll write just a into 1 upon a is already there. So this will get cancelled. You are getting 1 upon root of a square minus a square. So what I've shown, derivative of this portion is exactly this, you see. Therefore integration of this is this. Remember, this is the general formula. Put a equals to 1, you will get this. For example, if I want to answer this, integral of 1 upon root of 4 minus x squared. Now this integral you cannot answer through this formula, remember, because here 1 is fixed. So what's the answer to this? This is equals to sine inverse x by a. Remember, what is a here? That's the square root of a square, which is 2, plus c. This is the answer. One more, I want to answer, for example, 1 upon root of, let's write 7 minus x squared. So how do I answer? Sine inverse x upon 7, you can write like this, you know, root 7 the whole square minus x squared. So it becomes this formula now. So by root 7 plus c, this is the answer. Right. Example number 1, example number 2. But the 15 number is this about sine inverse, remember. If you are just 1, then it is our standard derivative. You can write cos inverse, but you need to put the minus sign. C then always minus sign, remember. But in general, if you have a here like this, 1 upon root of a square minus x squared, then sine inverse x by a plus c, remember. Okay, next. 16 number here. So that is integral of 1 upon 1 plus x squared. You know this is a derivative of some standard function. That's a tan inverse. What's the derivative of tan inverse? 1 upon 1 plus x squared, which is same as minus cot inverse, you know, plus some constant c. This one you know. Derivative of tan inverse x is this. Derivative of cot inverse with minus sign is this. So that's one thing. But here in general you may have like this, x squared plus a squared, remember. If you put a equals to 1, you will get exactly this. So here the formula is you have 1 upon a tan inverse x by a plus c. So again I'll verify for you. You differentiate this by chain rule, you will get exactly this. See, I'm differentiating. 1 upon a being constant as it is, differentiation of this one. 1 upon 1 plus, imagine this as x. So x squared by a squared by chain rule into, by chain rule differentiation of this one, x by a. Differentiation of x is 1, a being constant as it is. Now if I simplify this, you see here a square will go over here and it will be in the numerator. So a square plus a square, this a and this a gives us a square. So this will get cancelled finally. You are getting 1 upon x squared plus a squared. That is what this function. Right? This is just for your information. I did the differentiation. You can also verify. So the next important formula is this. If you have 1 here, it is just this one. For example, I have this 1 upon x squared plus 9. Now in this case, you cannot use this formula because here it is 1, here it is 9. So how do I rewrite? I can write like this, x squared plus 3 square. Now it's just this formula, a equals to 3 here. So I have 1 upon 3 tan inverse x by a, that is x by 3 plus c. This is your answer. Plus c, we always put in integration. One more here, just to clarify this formula. I have 1 upon, let's write x squared plus, let me write 25. So this is equals to 1 upon x squared plus 5 squared dx. So what is the answer here? 1 upon 5 into tan inverse x by a, that is x by 5 plus c. This is the answer. If you differentiate these, you will get this. If you differentiate these, you will get this. Just I'm telling you, in every question, no need to verify. You need to use the standard formulas. Next is integral of 1 upon x into root of x square minus 1. You know that this is the derivative of sec inverse x plus c here. If you differentiate this, you will get exactly this. Or in terms of cosec inverse also you can write, but you have minus cosec inverse x plus c. If you differentiate this, you will get this. That you know. But here the general formula is, if I have like this, 1 upon x into root of x square minus a square, remember, which is given by over here 1 upon a into sec inverse x by a plus c. This I leave it for you. You differentiate this by chain rule, you will get exactly this. But this you need to remember. What's the difference between this and this? You put a equals to 1, you will get exactly this. So what you have noticed is here, in the formula of sec inverse, you have 1 upon a in front of it. In the formula of tan inverse also you have 1 upon a in front of it. But in the formula of sine inverse, you don't have 1 upon a, remember, it is just sine inverse. You are not having 1 upon a. So keep this difference in your mind. Okay. We have some more formulas. Integral of 1 upon x square minus a square. X square minus a square, which is, I'm writing without proof, 1 upon 2a log of always mod here. It has two factors, x minus a factor, x plus a factor plus c. For example, if I have this x square minus 3 square like this, so 1 upon 2a, a is 3 here, into 3 log of mod of x minus 3 upon x plus 3 plus c. This is the answer. The next here, similar formula, that is you may have, it is just based on these only. 1 upon, I'll take a square first, constant first, x square minus a square. So which is 1 upon 2a. Now here plus factor will be in the numerator. So log of mod of here a plus x upon a minus x. If you think for a while, the only difference between these two is minus sign. So that because of that power, this factor get interchanged. Here minus factor in the numerator if you have x square minus a square. If you have a square minus x square, then plus factor in the numerator. Okay, so one more based on this. This is the main formula. Just from there we have this. The next one, 19.1 here. We have 1 upon root of x square minus a square. I must mention here, you see the difference between this and this one, 15.1. There you have root of a square minus x square, constant first. Answer is in form of sine inverse. Here variable first, and here it can be shown that the derivative is, integral is log of mod of x plus the same expression. How do we prove this? This is homework for you. Differentiate this properly. You will get exactly this. This is home task. You must do. Find derivative of this. Ignore modulus, that's not important. You imagine this is x by chain rule. Differentiate, you will get exactly this. 1 upon root of variable first, answer is in form of log function. Here constant first, you see both are same formula, this one and this one. The only difference is here in these two. Variable first, answer is in form of log function. Constant first, 15 number, constant first, answer is in form of sine inverse. So be careful when you use this. Inside the square root, variable first, inside the square root, constant first. Okay. And same way, you may have plus sign here. It may be like this here, root of x squared plus a squared, which is given by log of mode of same formula, x plus the same expression. Remember here minus, therefore here minus, it's not there. X squared minus a squared, log of mode of x plus the same expression. 1 upon root of x squared plus a squared, log of mode of x plus the same expression. Okay. So these are the list of important formulas. We'll see further in the next session.